Hello? Oh, okay. There you go. Let's see. Okay. Great. Well, oh, that's a little too loud, probably. How's that? Okay. Well, thank you very much. It's a real pleasure to be here. Thanks first to Carlos and Tomaso for inviting me here. It's been a great trip. I've really enjoyed the beautiful location. I enjoyed it a little bit too much yesterday. I'm a little sunburned, but it's been a real pleasure to be here. Your the workshop in general that you're about to see, and in my talk in particular, is a little bit different than what you're used to. You're used to seeing talks on science, how science is done, what different people's research, different techniques that people are using, and what we're here to talk about, and what I want to talk about is once you're done, once you have your results, your calculations, those of you who have published know that you're not done. There's a long road ahead with writing the paper and getting the paper published, and that is a job in and of itself, and it's also a very, very important job because you spent all this time and energy and work doing the research. It's important that you reach as large a community as effectively as possible. You want to be persuasive in how you present your results so that people will pay attention to what you're doing. You also need to be persuasive in order to just get your papers published because editors are paying attention to how effectively your paper is written, how well you match with the readership that they have, and so various speakers will talk about that. What I'm here to talk about is how to write a paper that is accessible as possible to as broad an audience as possible. You don't want to just speak to your advisor or to the specialist in your field. You want to try to, particularly for journals like Phys Rev Letters, Science and Nature, you want to be able to communicate to a broad audience because the readership of those journals is quite broad. And I want to reiterate what was already said, which is that if you have any questions along the lines during my talk, please stop me and ask. I'm happy to answer them. So what I want to talk about is various things that you can identify that are stumbling blocks to having somebody read your paper and how one goes about writing a paper that can be read as accessibly as possible by a broad audience. And a lot of what I'm going to say is informed by a variety of things. One, you've already heard of Celia Elliott, who was really unhappy she could not be here, but she and I teach a course at the University of Illinois, which is about communicating physics research. And interestingly, it's one of the more popular physics courses that we teach, even though it's about communication, and it draws from a variety of different disciplines, not just physics. So we get engineering students and staff that come to attend this course. And so some of what I'll talk about are bits of what we talk about in that course. The talk is also informed by Dr. Saad Haboul, who was an alumnus of the University of Illinois. He came and gave a talk as part of our Physics Careers seminar series, and he talked about how do you get your paper published in Phys Rev Letters. What kinds of things do they look for, and what kinds of writing styles that are important. There are also a couple of good so his talk can be accessed via this link here. And there's also a number of papers. You heard one by Carrie Friedman that is worth looking at, but there's also this paper by George Whitesides. He's a very well-known Harvard chemist, and he wrote an article about how his group writes papers that are accessible, and I'll allude to those as I go along. Okay, so with that, let me just reiterate that when you're done taking your data or doing your calculation and you're trying to decide whether to write a paper, how to write a paper, where to submit the paper, this is a very important part of the process. And so you have to realize, even though you're exhausted from all the work you've been putting into the actual research, that it's important to be very careful in the manner in which you convey your research, because how effectively you convey it can really impact how well people will understand what you're trying to say, and even cite your papers and believe what your results are. So this is a very important part of the process, and this is what we're emphasizing in the workshop and the talk today. One person who commented on this particularly is this George Whiteside's article, where he talks about writing as not an end stage of the process where you think about, okay, I've taken my data now, I've stopped, and I'm going to go and write the paper. He emphasizes that the writing process is actually an iterative process. Now, of course, you don't want to write your paper before you've gotten any results. You want to wait until you have something which looks promising. But he emphasizes that it's part of the process where in the course of writing, you can identify regions where you might need to take, you might need to identify some places where you have holes in your logical argument, and you might need to do additional experiments or do additional calculations. And it also can help you plan your research. So he sees this as an iterative process, and I agree to a large extent that's the case. Again, another interesting talk that I will allude to is this talk given at Illinois a few years ago by Saad Habul, where he gave a special seminar on how to get what are the characteristics of a successful manuscript submitted to FISREV letters. And it's a very informative discussion, and I'll allude to some of the things that he talked about. So one of the first things, and these are the different components that I want to emphasize, and one of the first things that I think is one of the most important is this, that the first thing you do when you want to write is you need to sit back and think about who your audience is going to be. Because your audience is, it can be very different depending on what the format of where you're writing. It could be to a very specialized audience that's going to know a lot about what you're doing. It could be to a scientific audience that's not specialized, so that will require a bit more care in the way you present things. And it could be a very, very general audience of people who are not even scientists. So your audience will dictate the level of your presentation, the kinds of material you include, the number of things you can talk about. But I wanted to emphasize not just identifying your audience, but you need to put yourself in the frame of the audience when you're writing. And this is a very difficult thing, because you are totally immersed in your own research. You're very familiar with it. You're getting feedback from people who are as familiar or maybe even more familiar with your research than you. For if you're a student, that's your advisor. You get feedback from specialists, and they know a lot about the material, and so it makes it easy for them to understand things that you're not effectively saying, because they can fill in the gaps. That's not the case when you send it out to a general journal. There are lots of things that you can't assume. And so one of the things that's very important about the writing process, particularly when you're submitting to to a high-profile journal that caters to a broad audience, is to put yourself in the mindset of the reader and avoid pitfalls that tend to make the reader say, okay, I don't understand what the point of this person is trying to make here, and derails them from the logical narrative you're trying to present. So that's the first thing. So the second thing that you want to do once you identify your audience is try to identify what the story that you want to tell is. Your story has to be coherent. It has to hold together. Of course, it has to be fact-based, so it's a factual story. But nevertheless, it's got to be a coherent story that you can communicate to an audience. And how do you go about doing that? And I want to argue one of the ways to do this is to sketch out an abstract and even an introduction once you have a lot of your data in or your results in, because these two components really represent the most elements of the paper that you're going to write, and they're usually easier to start with than just sort of stream of consciousness starting in on your paper. After you've formulated your story and you've convinced yourself you have a coherent story to tell, you want to be able to tell that story in a narrative that doesn't constantly derail the reader from understanding what you're trying to say. And this brings us to creating an outline that I'll talk about as well. And finally, once you have your logical arguments sketched out via an outline, there are little tiny disruptions that tend to crop up in writing that you want to avoid, that make it difficult for the reader to follow what you're trying to say. Because while you're trying to communicate something in a coherent fashion, these little tricks tend to crop up and cause the reader to forget what you're trying to say, have to refer back to something else in order to understand what you're trying to say, which tends to keep them from following the narrative you're trying to tell. So these are the elements that I want to talk about through the rest of the talk. But again, any questions, before I... Okay. All right, so this is the outline of a Fizerev letter that Saad Habul laid out. You're going to be very familiar with it. It's got a title, it's an abstract, introduction, the main text with figures and equations, conclusions and references. And the two parts that I want to emphasize are the abstract and the introduction, because these are the ones that really are, in some sense, have to be the most accessible to an audience. And as I'll discuss tomorrow when I talk about how to respond to referee reports, this tends to be what editors and referees first look at in order to formulate an initial opinion about your paper, which can be very important. So the reason I suggest looking at an abstract to try to decide whether or not you have a coherent story to tell is because, first of all, it's got all of the components, or it should have all the components of your paper. But it's much easier to write. You can write it in a much more succinct way than just sitting there and trying to write the entire paper. Because the abstract should say what you want to do, why you want to do it or why you did it, and what was significant about what you did. So the abstract gives you an opportunity to make sure that you have a coherent story to tell, particularly one that you've sort of drafted out, without having to spend a huge amount of time writing an entire paper. And it could tell you that, okay, well, there's something wrong with this story, something doesn't make sense, and maybe we don't have a coherent story, maybe there are things we need to do in order to fill in the gaps in the logical narrative we want to present. So what should be in the abstract? So the abstract should more or less contain, in this order, first, a brief statement of the motivations of the work that you're doing. It should be followed by a short description of the methods that you're using. It should have a summary of the key results, even with quantitative information. And then finally, it should have a statement of what the implications of those results are. This is really, and you can see that this has every aspect of the paper that you'd like to have, but in a very concise, contained form. So this is why it's a nice thing to kind of sketch out to make sure your story makes sense. One of the other reasons I emphasize this, and one of the reasons that I came to think of the abstract in this way, is it's becoming increasingly common, at least in the US, for funding agencies, before you submit a proposal, to tell you to submit what's called a white paper, which is usually a 1 or 2 page synopsis of what you plan to do. And that forces you to sit there and write in a very coherent fashion what your research is going to be and why you want to do it, and it really forces you to think very carefully. And in the process of doing this for a number of funding agencies, we realized that in some cases we hadn't really thought through some of the things that we wanted to do, and that made it very easy. Writing an abstract made it easy for us to talk through some of the details that were not quite working. So by the same token, an abstract in a paper can help you think through whether or not you have some coherent story and whether you need to do some additional research in order to fill in the holes. So here's a great example, I think, of an abstract. The phys rev letter requirement for abstract is it limits it to 100 words, so it has to be extremely concise. And so in abstract, literally, those 4 different components can literally be just one sentence. But you can see how well this group did it. They have the motivation. Transitions between spin-split bands by spin-orbit interaction are relevant to many novel phenomena, etc. That's the big picture motivation. They follow with the methods. We perform optical spectroscopy measurements combined with first principle calculations to study these transitions. Very concise statement of what the methods are. Then a statement of the results. Several novel features are observed in the optical spectra, including a sharp edge singularity due to reduced dimensionality, etc. And finally, what are the implications of these results? In one sentence, these confirm the nature of Rashba type splitting and manifest the relativistic nature of the electron dynamics. So again, in 100 words, they basically tell the clear story of what you want to say. And what's nice about this is that you can expand this by just elaborating on each of these 4 points into the larger paper and even into the introduction itself. And you'll see how that's done. So this is a very nice way to make sure that you have something that is going to be coherent to an audience and is well contained. Questions? Okay. So this is Celia. Celia likes to frame this in terms of a menu and a recipe, which is what you want to do to establish these 4 components of your abstract is write out answers to these questions. The first is, what problem did you study and why is it important? What methods did you use? What were your principal results? What conclusions can you draw from your results? And what are the implications of your results? So you want to make your answers as specific as possible. You can expand or contract the length as needed, depending on what your needs are. But you can basically build on this and build an entire paper out of this in principle. Okay. So if there are no questions about the abstract, the next portion of the paper that needs to be accessible is the introduction, because this is also often something that is the first thing that people will read, including the editors, but certainly the readers will often skim the introduction before deciding whether to read your paper. So I want to talk a little bit about this. Again, the introduction, like the abstract, generally contains all of the elements of the paper itself, so it's a nice thing to start with. I don't necessarily recommend starting with the introduction because it can be difficult, but it's not a bad idea to sketch it out and then go back to it as you finish the rest of your paper and refine it once you've completed most of the rest of the paper. So again, an accessible introduction provides the motivation and importance of the research that you have. It provides the necessary background information that you can rely on later on in the paper that helps the non-specialist reader understand some of the details of the field, provides a justification why the research that you're doing is needed, and then provides a preview of the key results of the paper. So this is how, and you'll note that this is much of what's contained in the abstract as well, so that they're very similar in that regard. The way Saad Habul framed it in his talk is the introduction consists of these 3 crucial parts: background or survey, physical motivation, and then what he calls the in this letter contribution. And one of the things I can encourage you to do to improve writing is, I know you're used to reading lots of papers, but you generally read them for content, which is great. But it's also a good idea to read for style. Look and see what common features that you see in the paper, the things that you like, that the authors are doing that you can incorporate in your own writing, and things that they do that you don't like. And so, yes, sure.
Please, the previous slide. Yeah, how to find the balance between your introduction text when you write for a broader audience and a specific audience? I mean, is there any recipe or something like that? Thank you.
Well, I mean, that's a good question. And first I would say, in general, you assume you want to write for the the least informed reader. So in general, I think even if you think you have a specialized audience, it's likely that not everybody is going to be as specialized and expert as you think that they are. So I think you should always try to write as accessibly as possible. But I think what that's going to control is how much background material you have. I think your motivation is always going to be very similar, no matter what the audience is. Even if it seems obvious that everybody knows what this motivation is for an expert audience, I think you want to reiterate that. But the background can be more or less, maybe less detailed if you know you're submitting to a journal that has a more specialized audience. But in general, the papers that I write to a more specialized audience and also to a general audience are not a whole lot different. I tend to write them all fairly accessibly. Yes?
In the previous slide, you had a very specific structure. This one.
Yes.
Where you put the equations in the main text. So if you want to write an introduction to a broader audience, are you saying that I should skip equations in the introduction?
In the introduction?
Yes.
I certainly would. I mean, I think that you want to get general ideas across. And I see this in a lot of what I say for papers, I think applies to presentations as well. But I've seen many theses from theory students where basically the first chapter is throwing out a Hamiltonian and just diving right in, and you're immediately going to lose people if you do it that way. So yes, I would say, look, I don't think there's any firm rule that don't include equations in the introduction, but I think in general you want to communicate in words what the idea is and what the motivation is. I don't know if any theorists want to pipe in here, but I think that's my sensitivity of this.
Good morning. My question goes along the line of finding how to write the background.
Right.
In case you're writing, let's say, about computer simulation, about something in physics, and to a journal that is specialized in computer simulation of something. But you are using a strategy that's not used in most cases. How do you find the balance between finding the background, even though the audience should have this background already?
Well, I don't think there's any problem with repeating information that people know. And this is a common issue in presentations where you say, okay, I know my audience is very expert. I feel silly showing them things that they already know. First of all, the audience likes it when they see what they know. It makes them feel good about themselves, so there's nothing wrong with that. And I think you can't assume who, particularly when you're submitting for a journal, who's going to read your paper. And I think, so people who know the material are not going to be too bothered by it unless you go into really excruciating detail. And people out there, and I'm sure there are some who aren't familiar with it, you're going to keep them engaged. So I don't think there's any problem with putting out information that you know the reader is most of the readers are going to know.
Another question?
Perhaps a quick comment. So I used to think, and I learned that many years ago from my former advisor and some other people, this philosophy of tell them what you're going to tell them, then tell them, and tell them what you've told them.
Yes.
So there's a great deal of, to some extent, some redundancy there.
Yes.
And also with the figure caps and then the text.
Yes.
But I think that's all fine, no? To reinforce your point.
It's not just fine, it's encouraged. So sometimes you will see people writing papers as if it's a mystery novel where they save the punchline for the very end and surprise the reader. You don't want to write a scientific paper that way. You have a main point you want to make. You want to make it many times. You make it in the introduction, in the abstract, you make it in the introduction, you make it in the conclusions. So again, the main points should be repeated because you don't want the reader to go away without knowing what your main points are. That's true of both of presentations and of papers. Okay, any other questions? Okay, So the introduction has these three components. We've already mentioned background, physical motivation. The way that Celia and I sort of like to communicate this is in terms of an inverted pyramid. And mostly this is not just because we came up with this. This is because if you look at the literature and you really start looking at papers not just for content but also for style, you will notice that, in many, many papers this kind of format for introductions. And knowing this organization can also help you write introductions, because it's not many people think the introduction is this sort of mysterious, difficult thing to write, but if you can kind of see the structure, it can make it a bit easier to write. So the idea behind this inverted pyramid is you open with a very big statement of where your research fits in with the bigger picture, and then throughout the introduction you slowly narrow the focus to what your particular part of that larger area of research is. So these are the three elements that Saad talked about: the big picture motivation of how this impacts the broader community that you're in. The provides essential background here, which slowly narrows the focus to something closer to what you're actually working on. And then it concludes with a preview of your results. The one thing we do add is that somewhere in most of these papers is a statement of however, where there's some problem. You don't end with just stating all of the background and suggest that the problem's been solved, but you put in a statement of where the deficiencies in our understanding of whatever the problem is, and how your research is going to solve that problem. And so to give you an example of this is one of many, many examples I could have used, but again, this is something that you can do on your own, looking at different papers to look at their style. This is a paper this is an area of soft condensed matter. They start off with examples of surface and interfacial growth phenomena are diverse, ranging from the production of uniform coatings by vapor deposition to burning paper due to combustion, to bacterial colonies whose boundaries expand and fluctuate as bacteria replicate. The morphology of the resulting interfaces is a property that affects the macroscopic responses of these systems, and it's therefore desirable to relate interface morphology to the microscopic rules. So that's the motivation, but you can see how they open big. They talk about how this particular issue is relevant to a broad community of people, which is really a requirement of Phys Rev letters. They want to make sure this crosses different areas of research. But then it narrows to focusing with specific background material that slowly narrows the focus to something closer to what they're working on. And in particular, you introduce specific topics that are going to be important to the research that they're talking about. So this is where you're narrowing down. One of the common issues that people have is, with all the vast literature that's out there in my field, how much background do I have? You can't put it all in. So what you want to do is you want to have something which is not only coherent, but is selected to emphasize things that your particular research is involved with, and that you can maybe use later on in the paper and refer to. And then finally, here's this however statement. So the KPZ class presents a rare opportunity for connecting exact theoretical predictions about non-equilibrium growth with experiment. However, to date, only a few members of the KPZ class have been experimentally identified. So this is where they're saying, okay, there's a problem, and they're obviously setting up the reader to know that we're here to solve this problem in this paper. And so they started from a very, very general statement of issues and what fields it applies to, narrows it down to a specific problem that still exists, and then they conclude with they don't call it the in this letter, they call it an in this contribution. We demonstrate that the rich non-equilibrium physics, blah, blah, blah. So this is where they do a preview of their results. And this is getting back to what Carlos said. So they're not waiting to tell you at the very end of the paper what they did, what their results are. They're telling you at the very beginning of the paper. They're putting some of the key results they have. They haven't proved them. That's what they're going to use the paper for, but they've highlighted what their main result is. Okay? So I'd encourage you to, as you look through papers, not just to read the content, but look at the style. How much does the style conform to this kind of format? Yeah, sure.
and this is also the place where, this sentence where you talk about what you're going to do is also where you stick your neck out if the field is controversial, because you have to take, at least that's my view. I always like to give a little bit of insight, and then that can cause trouble because if there are controversies in the field, then it may go to this or that group, and then. But you have to take the heat to some
Well,
extent.
as long as I mean, what's assumed in this preview section is that you're going to prove it at some point in the paper. So as long as you're going to come back and demonstrate that, yes, I think that's fine. Okay, any other questions? Okay, so how do you, now that you've formulated a coherent story, how do you write the story so that you can keep the reader along for the ride, going from the introduction to proving your point? And the kind of a metaphor that Saad uses that I liked, that I want to convey, is he kind of used this as like a windy river, where you start off in the introduction and the reader follows along smoothly with no disruptions to the conclusions and follows completely your logical flow, and at the end says, this person can't be wrong, and I believe what they're trying to tell me. And what you want to avoid is the way he described it as diversions. So there are little things that you can do in your writing on various scales, from the large scale to the small scale, that kind of derail the reader from this narrative that you want to tell of this story that you have. So you have this very clear abstract which tells very succinctly what you want, what your motivations are, what you did, what your results are, and why you did them. But then somehow when you write, you introduce things that cause people to go, okay, what? I didn't follow what they're trying to tell me. And what are those? Well, on the largest scale, and we all know this, it's the logical organization of what you're trying to say. We've probably all read papers that we cannot follow the logic of what the person's trying to tell me because it's not organized in a logical fashion, or there are logical leaps that are there that we can't follow. And these are also the hardest things to help fix when you're editing somebody's paper. So how do you create a logical flow in your paper to begin with? Well, the best way that people have come up with, or at least one of the best ways, is to create an outline from the very beginning. And this is something that's really emphasized in this Whiteside's paper, and I'll just read his quote. So, I emphasize the central place of an outline in writing papers, preparing seminars, and planning research. An outline is a written plan of the organization of a paper, including the data on which it rests. You should, in fact, think of an outline as a carefully organized and presented set of data, objectives, hypotheses, and conclusions, rather than an outline of text. So he considers this as part of the entire process of the research experience. So you've seen this, right? This is just an introduction. So you want to start with a very sketchy outline, but then you want to build more greater detail in each of the sections. So you don't stop with just this kind of gross, large-scale outline, but you break it up. So within each section, you're going to outline exactly what you're trying to say in different steps. So for example, in the introduction, I want to start with this big picture statement. You may even comment what you think it's going to be. Don't worry about the wordsmithing. By wordsmithing, I mean don't worry about the grammar and the details, because that's really hard and you can fix that later. Worry about the logical structure first, and then you can fine-tune the writing later. One thing I also want to say is, because as I said in Sao Paulo when we talked, one of the common things that students come into our class saying is, my goal is to not have to rewrite a paper. And our answer is we can't do that. You have to expect to rewrite. Even the best writers will rewrite. So what you want to do is you want to write it as effectively as possible the first time, so the rewriting is minimal the second time. And again, the hardest thing to rewrite is something with bad logic, which is why creating an outline is very important. So, so in each of these sections, you can break out and sketch out for yourself what you want to say, and make sure there's a logical flow to that. When Celia gives this talk, she says that she actually doesn't just write it on paper. She puts index cards. And she has index cards because the index cards allow her to shuffle things around and change the order, so that it's easy to adjust things to see whether that improves the logical flow. But start from an outline. One of the benefits of an outline is it creates the logical structure at the very beginning, and you can more easily see where, okay, I don't understand this gap in the logic, or there's something missing here that I need to improve. It keeps you from writing extraneous information. So one of the things that derail the reader is some tangential remark that doesn't have anything to do with what you're trying to say. And if you write just stream of consciousness, that's easier to include in your writing. So writing an outline allows you to sort of put just the minimal amount of information that's needed to make the point that you're making. One of the biggest reasons, particularly if you're getting ready to write a thesis or write a review article, is that an outline allows you to write sections of a paper rather than worrying about trying to write a large manuscript all at once. You can break it up into smaller pieces that are more manageable. So a second thing that you want to do that's sort of a large-scale issue is to bring out the main ideas of this outline. So this outline is a list of the main ideas that you want to convey constructed in a logical order. How do you convey those main ideas as effectively as possible in your writing? The best way to do that is to use a paragraph structure. And a paragraph really should contain ideally one idea. And it should be constructed, and again, you get differing opinions, but the most common way is to have the main idea at the beginning of the paragraph, have that idea supported in the body of the paragraph, and then have a transition, logical transition to the next paragraph. The paragraph structure is a way of jarring the reader out of their boredom when they're reading to say, okay, something new's coming. It's you, the author, telling the reader, okay, this is a new idea. If you don't have a paragraph structure, then people can lose the main ideas buried in the text. So let me give you an example of this. So one of the things that we do in this course is Celia has taken a bunch of writing in Phys Rev letters that illustrates some bad habits of different kinds, and our students are expected to go through and fix those problems. So here's we have a paragraph assignment where they're supposed to fix the paragraph, and here's the assignment. This is from an actual Phys Rev letter, and this is the entire introduction. And this introduction has three or four ideas buried in it, and it's really hard if you read it. And I'm not going to read it to you, but it's very hard to piece together what it is. And the students have to go through and create a paragraph structure which is better. And this is there's no unique answer, but this is one. And here you can clearly see the topic sentences at the beginning of the paragraph. There are then transition sentences that transition from one paragraph to the next. And then, but you can just pick out the main ideas. You can understand the basic details of this paragraph just by reading the topic sentences, without any support from the bulk of the paragraph. And you can also see this introduction, this format that I talked about with the introduction more clearly here. So here's the big picture opening: high pressure, temperature, phase transitions of dioxide, interest in solid state physics, chemistry, and geosciences. This is the big picture. Here's the narrowing with the background information, and then here's the however statement. Unfortunately, because no dioxides in the high pressure crystal structure have been reported, blah, blah, blah. This is the, okay, there's a problem, and we're here to solve it. And this is the in this paper or in this letter statement. So now you can clearly see not only the main ideas, but you can clearly see the structure of the introduction that I talked about earlier. But again, so identify what your key ideas are, and help the reader along by using them in different paragraphs so the reader knows, okay, something new is coming and I want to pay attention to this. One way to connect the outline that you've created to a paragraph structure is, instead of just having little bullet points for your outline sections, is to write out the bullet points in full sentences. And those sentences can become your topic sentences in the different paragraphs. So this is another common thing. This is called a sentence outline that many people use. Okay, questions about this? Okay, so those are a couple of the big picture kind of structural disruptions that can disrupt the narrative flow. our class and also SOD emphasize some smaller scale disruptions that can, even if you do have a logical structure in your writing, keep the reader constantly stopping and saying, okay, what does this person mean? So it disrupts the narrative flow. And this happens even within a sentence. So you can take this river analogy and you can say at the start of the sentence, I'm going along smoothly. I get to the end of the sentence, you understand it, it's an idea. But there are these disruptions that cause me to stop and have to reread something instead of trying to understand what the writer is trying to say. So there are many, many of these, and I don't want to go into all of them, but some of the most common are the following. Avoid abbreviations, avoid acronyms, avoid jargon. This is terms that people don't know, that you know in your field, but outside the field nobody knows what they are. Avoid colloquial phrases. So here's the example that SOD used. So the measured PL spectra of a single 1 micron long SWCNT that encapsulates a chain-like agglomeration of colloidal ZNS, QDs appear to be shifted with respect to PL spectra recorded from an empty SWCNT. So many of you probably know what these things mean. The writer knows what they mean. Their advisors probably know what they mean, but many readers don't, and they have to stop and try to figure out what it is instead of reading the entire sentence and understanding the main idea that's being communicated. So the solution is to write the acronyms out as much as possible. In many cases, you don't save a lot of space by writing the acronyms. If you do use an acronym, define it. Very first usage. But even if you do that, it's still a disruption if the reader has to constantly go back to the front of the paper in order to remember what that acronym is. So try to avoid them. Avoid colloquial phrases. Avoid jargon terms that are only for specialists, and it can be really tricky to identify what they are. Jargon terms are one of the most insidious things in writing because you get so used to them you don't even recognize them as jargon. So one thing that I really recommend you do in writing is have one of your friends who's outside of your field read your papers to see whether they understand what you're trying to say. So here was SOD's fix of that sentence. Just spell out these words. Okay, so that's one form of disruption. Another are long, unwieldy sentences that contain more than one idea. Ideally, you'd like to have each sentence be one idea. Again, just like a paragraph reminds the reader that there's some new idea coming, the end of a sentence says, okay, there's something new coming in the next sentence. And there's no firm guidance for this, but Celia likes to quote this 20 to 25 words per sentence. So if it gets much larger than that, you have to wonder whether something's wrong or not. So here's an example that we use in our class. This has 54 words in it. And I won't read it, but it's just an agglomeration of a bunch of information without any pause, any stops. And a typical fix for this is to break these sentences up if it gets much longer than about 20 or 25 words, and try to break it up into multiple smaller sentences that are easier to parse by the readers. So here's one way of doing that. We can break this up into 3 sentences which just have 3 specific statements, and makes it much more clear. Some students think that it's more clever, smarter to write longer, unwieldy sentences. It's not. It's just confusing the reader. It's contrary to your goal, which is to communicate your research as effectively as possible. So break things up if you start to see these sentences get too long. Yes? No, I think a footnote is it depends on how important the footnote is, right? So a footnote can be just as disruptive, right? I've got to stop and go to the back of the paper. Now, if it's, so when you use a footnote is if it's additional information that really isn't critical to understanding what you're saying in the text. Some side information is fine. You don't want to bury key information in a footnote that the reader, if they decide to ignore it, needs to know. So there are uses for footnotes, but you need to make, and it's this. You can say the same thing about supplementary material and appendices. You know, when do you use supplementary material? When do you use appendices? You want to make sure that it's not necessary to understand the paper. That the paper should be self-contained. Okay, so ambiguous pronouns is another common one. So ambiguous pronouns are things like it, this, that, they, etc. These are things that when you say them, you don't know what the author is referring to in the previous sentence. So here's a good example of that. In Landau's theory of phases, different phases are classified whether the state of the system obeys or breaks the symmetries. In turn, this gives rise to local order parameters which can be measured to determine which phase the system is in. So if you're the author, you know what this refers to, and maybe if you're in the field, you can infer in the context of this paragraph what it refers to. But if you're not familiar with this field, you may have no idea what this refers to. So this is a very common thing you see in writing, and try to avoid it. So the trick is just to, there's no problem with just repeating a noun, right? Just to be clear. So clarity, I know, in fact, I talked to somebody at Sao Paulo saying, but you don't want to repeat words, right? And I said the clarity is the most important thing. Even if you have to repeat a word multiple times, if it's necessary to be clear in your writing, then that's fine. Use active verbs. So tell the reader at the very beginning of a sentence what the action in the sentence is. Don't bury it at the end. So here's what I mean by this. So scaling functions for both gauge invariant, non-gauge invariant quantities across topological transitions driven by non-abelian gauge potentials have also been derived. So here's the verb, here's the action, and it's at the very end. I've got to wade through this entire sentence before I understand what the action of the sentence is. Just move it up. So scaling functions were derived for both gauge invariant, non-gauge invariant quantities. So this is a way, it's a very common structure to put the subject but put the verb fairly early on in the sentence so we know what they're talking about. Another thing is to replace these sort of lengthy verb forms into active verbs. So instead of saying it is revealed that highly non-resonant dissociated channels can dominate, you can say the parameter range reveals that highly non-resonant dissociated channels can dominate, etc. Avoid unnecessary qualifiers. This is also something that happens a lot. So you'll see things like this. The electron photonic coupling matrix elements for different phases have been computed in the Brouillon zone on a reasonable Q-point mesh obtained from a sufficiently dense K-point. What's confusing about this is that we don't know what reasonable is. We don't know what sufficiently dense is. If it's important for us to know what sufficiently dense is for the context of the paper, define it in a quantitative way. If it's not important, remove it. So this could be simplified. And the goal here is just to make the sentences as short as possible with removing unnecessary information that's not helpful to us to understand the main point of the sentence. And finally, here's another common problem is maintaining a parallel structure. So when you write a list of things, it can be confusing. One of the clues that you give the reader that you're making a list is to use the same form of the verb before each of the components of the list. And here's an example where they don't do that. The project will proceed in 4 stages: review of the literature, designing the optical trap, construction of the optical trap, and data taking and analysis. Now you may be able to understand this, but there's something just bothersome about it a little bit because they're switching between the different forms of the verb, and it causes the reader to wonder what's going on rather than think about what the writer's trying to say. So you want to use the same ing form of the verb in this case is one way of doing it. So reviewing the literature, designing the optical trap, constructing the optical trap, taking. Using that ing form before each element tells the reader these are different components. And there are some examples where it's confusing which are the components of the list if you don't use that common form. So just to conclude, the main points are that you want to start with a coherent story. Of course, that's probably the most important thing to make sure you can do. And one way of doing that is to try to start simple. Start with the simple abstract, which is a much shorter but completely self-contained part of the paper. Make sure that you do have a story to tell. But even before that, you want to make sure you can try to get in the mindset of your audience. Remember that you're writing for your audience, which can be very general, not just for yourself, not just for your advisors or experts in your field, and make sure that you are filling in the gaps that you don't need so that they understand what you're trying to say. Create a logical story, a logical flow to your story by starting with an outline. So an outline will allow you to construct the story you want to tell in as logical a fashion as possible without extraneous information and without missing any holes, holes in the ideas that you're trying to communicate. And finally, avoid these common disruptions, and I mentioned two classes of them, these large-scale disruptions like burying ideas in the middle of a paragraph of text without having paragraph structure, but also smaller scale things like acronyms, jargon, unwieldy sentences, etc. So if you can kind of clean this up, and again, you can't expect to do this in a first draft, but these are things to try to do when you do your first draft so that when you do rewriting, it's much easier and takes much less time. So with that, I'll take any other questions you have.
So first, let's thank Lance again. Questions?
You said something about principle for beginners. In recent months ago, I started to write scientific works, and I realized that the difficulty is just because sometimes you don't have all the calculations, and you need to know the answer when you start to do your introduction, for example. So can you give me some tip or something?
Well, this is a really tricky gray area, and when's the right time to start, and do you have enough results to actually start? Obviously, you need to know something that you think you want to say. So it depends on how far along you are. But I do think you don't have to think of the writing as being something you have to be absolutely completely done in order to start. So if you have enough to have a pretty good idea that you think you know what's happening, but you just need to work out some of the details in the calculation, I don't think it's a problem to start drafting parts of the paper. Maybe an abstract is very easy. It's easy to write it, and it's easy to change it if your answers change as your calculations evolve. The methods section is often very easy, right? You can write that because you know what your methods are. So that's usually one of the first things that people write, because even though their calculations are not completely done and they're not quite sure how the idea is going to gel, they know that the method section is there. Another thing is parts of the results sections can be one of the first things you might want to write, because while you might not have all of your results, you may have some. But I think you have to get to a pretty advanced stage in your calculations before you can get started in any of this, because if you have no idea what you're doing or what the answer is, then it's, as you say, it's very hard to write anything. But there are sections you can write. Method sections you can write. If you're sure you're going to write a paper, you can start with the method section.
So, for example, can I just write all the calculations without concerning about the main text, or should I write some comments in between the main text of the calculations? I don't know, and I'm trying to use some strategy, like a pattern or something, but I noticed that write all the calculations, have done the calculations, and try to write comments and text between them. It's more easier, but I don't know if it's right.
You mean in the actual paper, or just notes?
No,
to yourself?
Just scientific work, not a paper exactly.
Well, so I'm not a theorist. I don't know how theorists do this, but I think you want to put as much details as possible in what you're doing. I mean, you should have a notebook. I would tell any experimentalist or any theorist to have a detailed notebook, so that in a year from now, when you've left this calculation behind, you can revisit it very easily and be able to tell what you're doing. So I think definitely you should put as many notes and as many details as you can. In the actual paper, it's really tricky, because you have a bunch of calculations, and you don't want to include the vast majority of them. So you have to identify what are the essential things that the reader needs to know in order to understand your main result. But certainly for your own purposes, you want to be as detailed as possible, have lots of notes, explain what you're doing, when you did them, any comments, as detailed as you can get.
More questions? I actually have a question about the repetitions you were talking about in
Yeah.
that example of the Landau's phase transitions. So sometimes it's also useful to use synonyms, for example, to substitute some words.
Sure.
So how much should we be worried about the synonyms?
So I had
and
exactly
finding-
this conversation with a student at Sao Paulo, and there are things that you can't, right? So his concern was electron. I'm like, look, what's the synonym for that? And so he was worried about repeating, very specific terms. So those things I don't think in trying to go to a synonym, you are being ambiguous about what you're trying to say, then don't use a synonym. And I don't think there's a hard and fast rule about avoiding repetition. Repetition is a stylistic thing, and stylistic issues are secondary to clarity. So if you think that you need to be clear to repeat a word, and there's some subtle difference in the synonym you're using that may confuse the reader, don't use it. Repeat. There's nothing wrong with repeating a word if it means that you're being clear about what you're trying to say.
Okay, thanks. So if there are no further questions, let's thank Lance again.